And here is classification. You do not need to encode. Okay, you do not need to encode. So the concept here is to calculate the probability only. So in order to calculate the probability, we can just calculate number of them, number of how many sunny, how many rainy, how many overcast. Just count. Okay, out of total how many. Then we can get the probability already. Okay, so we do not need the encoder here. Okay, so for this set of data, we have 4 input law: outlook of weather, temperature of weather, humidity of weather, windy or not, and then conclusion is go out to play or not, yes or no. Okay, so this is the historical data that we have. So anytime I can have a new data, sunny, hot, humidity low, a normal, for example, and then windy, false, then I can predict going out to play or not to play. Okay, so the concept here to work this out is by calculating the probability. So for example, if I only concentrate on outlook, then I close all the temperature, humidity, and windy. Then I will only check outlook and play. Okay, so I can build a table for outlook. Okay, so under sunny, how many yes, how many no? Okay, so under sunny, I have 1, 2, 3, 3 no, and then 2 yes. Rainy, I do the same thing. No? I count, I have 3 yes, and then I have 2 no. Overcast, I have 4 yes and 0 no. Okay, so this is the table I'm going to get. Okay, this is first 2 column, yes or no, just number of them only. Another 2 column at the back is the probability. Okay, so sunny and yes going out. Okay, the probability is 2 out of 9 because under yes there are 9. Okay, so 2 out of 9. Then rainy, yes, is 3 out of 9. Okay, 4 here is 4 out of 9. So for under no, total is 5. So 3 over 5, 2 over 5, 0 over 5. Okay, so this probability table is built based on outlook only. So you can do the same thing for your temperature, humidity, and windy, correct? Okay, so this is what we are going to do. This is for temperature. This is for humidity. This is table for windy. So I have 4 tables now. Okay, so based on these 4 tables, I want to find the probability can play the game, can go out to play the game. Okay, so I will look at it based on outlook, based on temperature, based on humidity, based on windy. Okay, because I have 4 of them. Okay, and I want can. Can means play is yes. So all based on play is yes. Okay, so outlook sunny, play is yes. Why is it 2 over 9? So you go back to the earlier table under outlook. Sunny and yes, this is the one. Sunny and yes, this is the one. Okay, probability is 2 over 9. Okay, so you get 2 over 9. Very easy only, this concept. Okay, and then temperature, cold, play is yes. So you go to the table of temperature. Temperature, cold, and yes, right? Cold is 3 Okay, under yes, so it's 3 out of 9, so 3 over 9. So you see the probability is 3 over 9. Understand? Now how about windy force? Play yes. Windy force. So you go to the windy table. Windy force. This is one. Play yes. So it's 6. 6 over 9 completely involved. And you get 6 over 9. Okay, so these 4 are count from the probability table by checking one by one. Okay, you check outlook, you cross the you don't look at the other. You check humidity, then you don't look at other. Okay, and the very last one here, probability yes, play yes. That means you just see how many total, how many data you have. Total you have 14 data You can count from beginning until the end, 14 data. and then 9 of them are yes. So it's 9 over 14. No? So this is probability on yes. Probability on yes. Okay, so these are the probability all involving can play. They are all in terms of yes. Okay, with the different weather here. And this is the weather that you want to predict. It's sunny, cool, humidity high, windy falls. You see? Then I break into 4 and check on their probability separately. Okay, at the end, you just have to multiply all these 4 together, which involve the play yes. Okay, you multiply all of them together. You get 0.0106. Looks very small. Now, how about cannot play? You do the same thing, but you change the play to no. Everything become no. Then you get the probability. You multiply all them out, you get 0.0137. Okay, so you get these two probability. Okay, actually they are not the actual probability yet. Okay, because you need a total probability of PS. Okay, for outlook sunny, temperature cool, humidity high, windy falls. Only these 4 happen together. You give you 0.0292. Okay, then you take what you have calculated now and divide by this 0.0292. Then it will give you the actual probability that it happened. Okay, this is the actual probability. So we see the 0.46 greater than 0.36. That means the probability on no, okay, not to play is higher. Okay, so you make a conclusions that no. Okay, with this kind of weather, not to go out and play. Okay, so if you have everything in terms of categorical data, this is the way how we solve. We also deal with probability, okay, but we observe every situations and get their probabilities one by one. Then you do a multiplications on all of them happen and see what is the value. And again, we will choose the one that having higher probability to make our conclusion. Okay. Okay, roughly know the linear Bayes, right? So just now LRT is the numeric data. This is categorical data, all categorical data. All of them are depending on probability. Okay, so when you come to building the model, again, you just call the library only. Okay, so this round, I call the Bernoulli NB. Okay, because it's all my data is the discrete data. Happen or not happen, windy is cool or hot, something like that. Okay, so you can fit everything in. Okay, so first you import library, second you import data set. If you want to keep for splitting for the data, then you need to apply the splitting part. If you think that no need, then you can just apply everything in to train the data. Okay, so at here, I still need the encoding. Actually, I do not need the encoding because we do the calculation. So theoretically, no need. But in Python programming, it really cannot understand the word. It can only understand the number. Okay, so we will just do the label encoder and not one hot encoder. Okay, we just do the label encoder. Later on, now you try to print out the X here to see what is actually happened. Because you have four attributes or 4 variables, which are humidity, temperature, outlook,